Okay, so as you can see, we're going to be looking at addition and subtraction of rational expressions. As I just mentioned, it is going to be a little more tedious, a little more work involved in adding and subtracting rational expressions. So if you look here at the top, the first one, we got 3 sevenths plus 2 sevenths. Well, we all know before you can add or subtract a fraction, you must have a common what? Denominator. And the question is, do we have a common denominator for this first one? Yes, we do. So how do you add 3 sevenths plus 2 sevenths? 3 plus 2, which would give you a 5. So we have the numerators. What about the denominator? What do we do with that? Stays the same. So we keep that denominator of 7. Therefore, our answer to the first one here is 5 over 7. So how exactly did we do this? Well, first we got to make sure we have a common denominator. And then from there we just add up the numerators and keep that same denominator. Okay, you don't necessarily have to write exactly like I did, but you do want to make sure that you put on there that we have to have a common denominator first, and then add up the numerators. Well, we're going to do the same thing with our rational expressions. These rational expressions that we're working with are the equivalent or the same thing as our fractions. So we've got to make sure we have a common denominator first, just like with fractions. So if you look closely at these two examples that they gave us over here, you'll notice that they have common denominators. So all we have to do is add up the numerators. So this first one here, the common denominator is an x minus 4, so I'm going to keep that. Don't need to change it. All you need to do is add up the two numerators. What do you get when you add 2 plus an x? 2 plus x. And since neither of these can be factored out, can't reduce it, that's it. That is your answer to that one right there. All we did was add up the numerators. Going right below it is the same idea. Notice how you have a common denominator again. So we're going to keep that denominator x squared minus 1. What we're going to do is we're going to add up the numerators. So we need to add 2x minus 3 plus 5x plus 7. Now, keep in mind when you're adding those numerators, you can only add like terms. So in other words, x's with x's, constants with constants. So what do you get when you add the 2x with the 5x? 7x. What do you get when you add the negative 3 plus 7? Negative 3 plus 7 is a positive 4. Again, we always want to see if we can reduce it. I can tell you this one right here does not reduce. So we're done with that one. That's our answer. So again, we've got to make sure we have a common denominator first. All right, number 2, we're subtracting this time. Notice how we do have a common denominator, so there's no need to change that. So if I subtract 8 elevenths minus 3 elevenths, the answer would be what? What do you get when you subtract those two fractions? 5 elevenths. All we're doing is subtracting those numerators. So 8 minus 3 is 5. So just like with the addition, got to make sure you have a common denominator first. Subtract those numerators. Keep the same denominator. So let's try that over here with our rational expressions. Again, we already have a common denominator, so there's no need to change the x plus 6. Just keep it. But we're going to subtract those two numerators. Again, make sure you're subtracting the like terms. So 2x minus the x. 2x minus the x would leave us with a x. One x. Now I'm going to subtract the constants. 11 minus 9. What do you get when you subtract 11 minus 9? 2. Positive 2. So I've got x plus 2 over x plus 6. The question is, can I cancel out those x's right there? No. Do not cancel out those x's. You can only cancel out common factors. All right, so that would be the answer to that problem. The next one, again, notice we already have a common denominator, so we'll just keep that 3x squared minus 4. What I need to do is subtract the numerators. So let's subtract. We've got an x minus a 9x. What's an x minus a 9x? X minus a 9x. What kind of 8x? Negative 8x. And 3 minus a negative 7. 3 minus a negative 7 would be a 10. What kind of 10? Positive 10. Again, if you can simplify or reduce it, you want to reduce it. However, this one right here does not reduce. So So we'll leave it just like that. All right, so these two examples is when we have a common denominator. Unfortunately, that's not always the case. Sometimes the denominators are not the same. So let's take a look at a couple of those. Number 3, we've got 3/8 plus 1/4. Obviously, they are not common denominators. Anybody happen to know what the common denominator here is? 8. Okay, so the denominator we're going to use is 8. So notice I don't have to change the first fraction. It can remain 3/8. However, the second fraction, we're going to have to change its numerator. So how do you change it? Well, remember, I went from a 4 to an 8 in my denominator. The question is, how did you go from 4 to 8? What did you multiply by? 2, which means you also have to multiply the numerator times 2. So 1 times 2 would be a 2. So 2/8 is the same thing as 1/4. They're equivalent to each other. Only thing here is now we can add them up. Now we have the common denominator. So here we're going to end up with 5/8. 5/8. So on this one, we had to find that common denominator first. Once we found that common denominator, then we can go ahead and add up the numerators. But you got to find that common denominator first. Let's not also forget that we had to multiply that 1 times 2. Got to make equivalent fractions. Multiply by that common factor. So we're going to take that same approach that we did with that example over there with our rational expressions. We're going to do the same thing. So notice over here they are not the same denominator. One has a denominator of 3x, the other has a denominator of an x. So the question is, what are we going to use for our common denominator? 3x. 3x is what we're going to use for our common denominator. Which means we don't have to do anything with the first fraction. It can remain 5/3x. Here's where it gets a little tricky. I went from having an x to a 3x. What do we multiply by to get from an x to a 3x? 3, which means you're going to have to take this thing right here, the numerator, and also multiply it by 3. So what are we going to get when we multiply 3 times an x plus what? 3x plus what? 3. So there's my new fraction. There's my new rational expression. At this point, you notice that we have a common denominator. So now we can go ahead and add these up. Let's keep that denominator 3x, and let's add the numerators. Anybody know what you get when you add 5 plus 3x plus 3? 3x plus 8. Question. Can I cancel out the 3x's? No, we cannot cancel out the 3x's. You can only cancel out common factors. 3x plus 8, that's one factor. That's all together. Okay, so don't try and cancel those out. All right, let's take a look at the next one here. It's the same idea. Notice we do not have a common denominator. So the question is, what is the common denominator? And we'll get a little more detail as far as how to find that common denominator in a minute. But anybody think they know what the common denominator is? 2x plus 4. 2x plus 4 is our common denominator. All right, so 2x plus 4 is our common denominator. We don't need to change that first one. It's fine the way it is. We're going to look at that here in a second. Okay? But notice here, I went from having an x plus 2 to a 2x plus 4. How did I go from having an x plus 2 to a 2x plus 4? In other words, what did I multiply by? You multiplied by a 2. We took this thing and multiplied it by 2, which means you also have to multiply this by 2. So 2 times 9 would give me a 18. Now I have a common denominator. Now I'm ready to go ahead and subtract. Remember, we are subtracting here. So I've got x plus 1 minus 18. Anybody know what x plus 1 minus 18 is? X minus 17. All we did was subtract the 1 minus 18. Of course, the denominator is going to remain 2x plus 4. So there we have x minus 17 over 2x plus 4. And again, like I said, I'll give you some more instructions on how exactly do you find that common number. The next one here, number 4, 3/7 plus 2/5. Obviously, they do not have a common denominator. Anybody think they got it? What's the common denominator for 7 and a 5? 35. So 35 is what we're going to use for our common denominator, which means we're going to have to change both of these fractions. How did I go from having a 7 to a 35? What did I multiply by? 5, which means you also have to multiply the numerator by 5. So 3 times 5 would give me a 15. So in other words, 15 over 35 is equivalent to 3/7. Do the same thing with your 2/5. We went from having a 5 to a 35. How did we go from having a 5 to a 35 for our denominator? Times 7. So make sure you multiply the numerator by 7 also. So 2 times 7 would be a 14. So now we've got these new fractions here. We've got common denominators. Add them up. 15 plus 14 would be a 29 over 35. So a little more work involved on that one because we did have to change both of our fractions. So again, find that common denominator. Multiply both the top and the bottom by the same thing. So in our case, we multiply the first fraction by 5 and the second fraction by a 7. This is how we came up with that 35 as our denominator. So what we're going to do is the same thing with our rational expressions. We're going to have to find that common denominator first. Then we can go ahead and add or subtract. So if we look over here, we've got an x and a 3. Anybody think they know what a common denominator is going to be for this one? 3x. 3x is what we're going to use for our common denominator. I went from having an x to a 3x on the first fraction. How do we go from having an x to a 3x? What do we multiply by? 3. So make sure you multiply the numerator by 3. So 5 times 3 is 15. So now we have the first fraction written as 15 over 3x. Do the same thing for the second fraction. I went from having a 3 to a 3x. What do we multiply to get from 3 to 3x? X. So make sure you multiply the numerator by that same x. So 2x times an x would give us a 2x squared. X times x is x squared. At this point, I have a common denominator. I'm ready to subtract. So I'm going to subtract 15 minus a 2x squared. What's 15 minus 2x squared? 15 minus x squared. There it is. There's your answer. 15 minus 2x squared. Okay, let's take a look at one more here. Again, no common denominator yet. So what is that common denominator? Here it gets a little tricky. Common denominator. What's that? FOIL method? Yeah. Y'all look over here what we did with this first fraction over here. We had a 7 and a 5 for the denominator. How did we get the common denominator? What do we do with those two numbers? We multiply. Look over here. We took the x and the 3. What do we do with those two numbers? We multiply. This is how we came up with our denominator. Well, we're going to do the same thing over here. We're going to multiply the two denominators to get that common denominator. Now, let me time out here. I say we're going to multiply these two to get the common denominator. But we're not going to physically do that just yet, guys, okay? So, what I want you to do is, rather than physically multiplying those two, I want you to go ahead and leave it in its factor form. In other words, don't do the FOIL method. Just leave it in its factor form. And you'll see why here in a minute. So the common denominator is going to be x plus 3 times 2x minus 1. Again, I'm not going to multiply it out just yet. And there's a couple of reasons for that. The first reason is it's going to make things a lot easier to see what we need to multiply the top by. So if you look here, I went from having an x plus 3 on the first fraction 2x plus 3 times 2x minus 1. So my question is, what did we multiply by to get that common denominator? 2x minus 1, which means we're also going to have to multiply the numerator by 2x minus 1. So what do you get when you multiply 4 times the 2x minus 1? 8x minus 4. So there's your first fraction. Second fraction. Again, I went from having 2x minus 1 as my denominator here to x plus 3 times 2x minus 1. Again, it's a lot easier to see what we need to multiply by. What's missing over here? What do I need to multiply the 7 by? The x plus 3. So if I multiply 7 times an x plus 3, we're going to end up with a 7x plus 21. So there's one reason we don't want to actually multiply that. It's a lot easier to see what we need to multiply the numerator by. Let's go ahead and add up the numerators. We got 8x plus 7x. 8x plus 7x is a 1x. A negative 4 plus 21. What's a negative 4 plus 21? Negative 4. What? 17. Positive or negative 17? Oh, we're adding. I saw that subtraction. It is addition. So it's 8x plus 7x. 8x plus 7x. What was that again? 15x. That is correct. 15x. Negative 4 plus 21. What did we say that was? Negative 4 plus 21 was positive 17. No wonder we had those puzzles on the face. All right, and our denominator, of course, is still the x plus 3 times the 2x minus 1. Now, here's another reason that we leave it in its factored form. Because at the very end, when we get this far, what do we always do with fractions? We always reduce them. So, this part up here, 15x plus 17, we need to check to see if we can factor that out and see if we can reduce this fraction. But is 15x plus 17 going to factor? Can we factor that out? No. So this cannot be reduced. But just like yesterday, I'm going to have you guys leave your answers in the factored form. Don't worry about going through FOIL method to multiply those two denominators, or those two factors in the denominator. Just leave it like that. Alright, so that takes care of adding and subtracting rational expressions. Now I can tell you the hardest part about this is finding the common denominator. This is where some of us are going to have trouble. The ones they gave us here, not that big of a deal. But some of these, they do get a little more intense. So let's take a look at the back side of your paper there. And let's focus a little more on how do you find a common denominator. Well, let's start with regular numbers. How would you find the common denominator for a 24 and a 36? If I gave you 24 and 36 as the denominator, what would be the least common multiple, or the least common denominator? What's the smallest number that both a 24 and a 36 would go into? I know. What's the smallest number that a 24 and a 36 would go into either? Does 24 go into 6?
72.
What? 72. 72. Notice how 24 will go into 72. 36 will go into 72. That's the smallest number. The question is, how do you come up with that 72? Now, some of us can do it off the top of our head. Other of us, not so lucky. So here's how you do it, or here's one way you can do it. Notice what they did with the 24. They wrote out its factors. Prime factors of 24 are 2 times 2 times 2 times 3. These are the prime factors of 24. Notice they also did the same thing with our 36. The prime factors of 36 would be 2 times 2 times 3 times 3. These are the prime factors. So if I want the least common multiple, or our denominator, common denominator, here's what we're going to do. Notice we got a pair of 2's here. So that's going to be part of our least common multiple. Make sure you're writing this down, guys. Notice this 2. We got another pair, so that's also going to be part of our least common multiple. And we also got a pair of 3's here. That's going to be part of our least common multiple. However, notice that we got two numbers left over. Do we just throw those away? Not quite. We need to include those numbers that were left over, which were the 2 and the 3. Now I want you to see what happens when you multiply 2 times 2 times 3 times 2 times 3. What number do you end up with? 72. And what did we just get through saying our least common denominator or least common multiple would be? 72. So this is how we're going to do it. Notice they give us another example. It's the same idea. Here we have 28 and 30. If 28 and 30 were our denominators, what would be the least common denominator? In other words, what would be the smallest number that both a 28 and a 30 would go into? Well, again, one way we can find it is by finding the prime factors of each of these numbers. 28, that would be 2 times 2 times 7. The prime factors of 30 would be 2 times 3 times 5. Once you have those prime factors, notice we got a pair of 3's here. So that's obviously part of my least common multiple. Notice there are no other pairs, but I can't just throw these numbers away. So I got to include all the numbers. I got a 2, I got a 3, I got a 5, and I also have a 7. So what do you get when you multiply all those numbers together? Multiply all those numbers for me. 2 times 2 times 3 times 5 times 7. What is it? 420. So believe it or not, the smallest number that 28 and 30 would go into evenly is 420. So we're going to take the same approach in finding our least common denominator in our rational expressions. All right, so you'll notice there's a couple of examples down there. Here's the first one. Here we have 2x over x plus 2 plus x minus 11 over x minus 4. And what we need to do is we need to find the common denominator first. So I'm doing a little scratch work. You notice down here in the bottom left-hand corner, I'm going to find that least common denominator. So I've got both of my denominators written down, x plus 2 and x squared minus 4. And what I'm going to do is I'm going to factor each one of those. Well, x plus 2. Can I really factor x plus 2? No, it's going to say x plus 2. Can I factor x squared minus 4? Sure you can. That's difference of squares. The factors of x squared minus 4 would be x plus 2 and x minus 2. This is difference of squares. So if I take that same approach that I was doing with the numbers, notice how we've got this right here. We got a pair of x plus 2. So that's going to be part of my common denominator. But I can't just throw away the x minus 2. That's also part of my least common denominator. So what I'm going to be using for my least common denominator would be this thing right here. So let me go ahead and rewrite this using that least common denominator. X plus 2, x minus 2. Again, notice that I'm not physically multiplying them out. I'm not using FOIL method. Here's what we're working with. So notice the first fraction, I went from having an x plus 2 to this over here, x plus 2, x minus 2. That means I'm going to have to multiply this numerator 2x times the what? What do I need to multiply? The x minus 2. That's what's missing. So if I multiply 2x times an x minus 2, what do you get when you multiply 2x times an x minus 2? 2x squared, remember using distributive property here, 2x squared minus 4x. Second one, I went from x squared minus 4 to x plus 2 and x minus. Well, if you think about it, isn't x squared minus 4? This right here is the same thing. So do I really need to change anything on this second numerator? No, we don't need to change that. It stays the same. All right, so at this point we've got our common denominators. Now we're ready to add up the numerators. Now remember, the denominator is going to stay x plus 2, x minus 2. Don't change that. So let's add up the numerators here. Let's start with the x squared. I've got 2x squared. There's nothing to add with that 2x squared, so I'm going to keep it 2x squared. I got a negative 4x plus x. A negative 4x plus x would be a what? Negative 3x. And I've got nothing plus a negative 11. Nothing plus a negative 11 would be a negative 11. And here's what I get when I add those together. Is that the answer? Are we done? We might be done. We may not be done. Remember, this is the answer I'm getting. Can I reduce that fraction? Well, how do I know if I can reduce the fraction or not? You're going to have to factor out the top part. Okay, so let's make some room over here. And let's see if we can factor 2x squared minus 3x minus 11. So the method we're going to have to use here is that bottoms up. So let's do bottoms up. Let's see, that's going to make this x squared minus 3x minus 22. So the question is, are there factors of negative 22 that would add up to a negative 3? And I multiply two numbers together to get negative 22, but would also add up to negative 3. Well, what two numbers can we multiply together to get negative 22? There's not a whole lot. 11 times 2, negative 11 times 2. Obviously, that's not going to get us anywhere near that negative 3. Is there anything else besides that? Well, negative 22 times 1, but that still doesn't get us anywhere near. So, can that 2x squared minus 3x be minus 11 be factored? No. So, does that mean I can reduce it? No. We're done. But notice that we do need to check that, guys, because sometimes you can factor it out, which means you might be able to cancel out some of those common factors. So double check. Make sure you factor everything out. Notice also how I left my answer. Notice the denominator is still in factor form. Don't worry about going through the FOIL method. All right, let's try the next one. Again, I need to figure out what am I going to use for my common denominator. X squared plus 7x plus 12. And 2x plus 8 is the other denominator. What would be the common denominator? Well, to find that, you're going to have to do some factors. So if I come down to the bottom here, let's factor x squared plus 7x plus 12. Let's find the factors. I know x times x is going to give me the x squared. What are factors of 12 that would also add up to a 7? Positive 3 and positive 4. 4 times 3 is 12. 3 plus 4 is 7. Let me come over here and factor 2x plus 8. Notice there's a GCF, and that GCF is a 2. So 2 is the GCF. What would go in the parentheses there? X plus 4. All right, so at this point, I've got it all factored out. Now we're going to use this to figure out what our least common denominator is going to be. Notice that I've got a pair of x minus 4. So that's going to be part of my least common denominator. Oh, plus 4, yeah. However, I cannot just throw away the x plus 3, and I can't throw away the 2. So I'm also going to include that as part of my least common denominator. So there's that, and I'll throw the 2 out here in the front. So all of that right there makes up my least common denominator. All of it. Let's bring that over here. So I've got 2, x plus 4, x plus 3, 2, x plus 4, x plus 3. Of course, that means we're going to have to change our numerators now. So let's come over here and check it out. I went from having an x squared plus 7x plus 12 to this denominator over here, 2 times x plus 4, x minus 3. Well, if you look down here at the bottom, that x squared plus 7x plus 12 has the factors of x plus 3 and x plus 4. So really the only thing that's missing is the what? 2. So that's what I need to multiply this numerator by, is that 2. So what do I get when I multiply 2 times the x plus 6? 2x plus 12. Let's go to the other one. 2x plus 8 was the denominator. Of course, I changed that over here to 2 times x plus 4 times x plus 3. Well, again, if you look down here at the bottom at the factors, if you look right there, notice we've got the 2 part. We got the x plus 4 part. The only thing that's missing is which part? The x plus 3. So that's what we're going to multiply by right here, is x plus 3. So if I multiply 5 times the x plus 3, that would give me a 5x plus 15. Alright, so now we're ready to subtract here. Let's start with the x's. 2x minus 5x would be a negative 3x. 12 minus 15. 12 minus 15 would be a negative 3. Of course, my denominator is still the 2 times the x plus 4 times the x plus 3. And as I mentioned earlier, if we can reduce it, simplify it. Now you'll notice over here, negative 3x minus 3. Can you factor that? Is there a GCF there? Huh? What's the GCF? Negative 3. Which means what would go in the parentheses? X plus 1. So yes, you can factor out the numerator. The denominator, I still got this going on. So this one, I've got everything factored. So the question is, will anything cancel out? No, nothing cancels out. Therefore, I am done. I can leave the answer like this, or I can leave it like this here. However, notice that I do have to factor it first before I can tell whether or not it can be simplified or reduced. So make sure you factor as much as you can. Because there will be cases where you can cancel something out after you factor that numerator. So be real careful. All right, we got one more to look at. That's this one right here. Once again, obviously you see that we do not have a common denominator. So let's find that common denominator. Tell you what, let me give you a chance first, and let me see if you can come up with the common denominator on your own. Find me the common denominator. Let's see how you're doing. The first one, x squared plus 6x plus 8. Anybody find the factors yet? X plus 4. Very good. Those are the factors. The next one here, x squared minus x minus 6. We also need the factors there. And what were those factors? X minus 6 minus 3 and x plus 2. Got to be those two, because a negative 3 times 2 would give us negative 6. And when I add negative 3 plus 2, I get my negative 1. So those are the factors. All right, at this point, we've got it all factored out. Let's find that least common denominator. Notice we got a pair of x plus 2, so that's part of it. X plus 4 and x minus 3, we can't just throw those away, so we'll include that as part of our least common denominator. So all of that, believe it or not, is going to be our least common denominator. So let me write that over here. X plus 2, x plus 4, and x minus 3. X plus 2, x plus 4, and x minus 3. All right, let's go ahead and find the new numerators, starting with the first one. Let's see. We already got the we look right here. We've already got the x plus 4 and we got the x plus 2. The only part that's missing is the x minus 3. So we're going to have to take this and multiply it with x minus 3. Anybody know what you get when you multiply those two together? Do some FOIL. What do we get? X squared minus 9 is what we get after we do FOIL method. Okay? But we're running out of time, so I want to make sure I get this complete here. If we look at the next one here, x squared minus x minus 6 was the original denominator. We've changed that over here. Again, if you look down here at the bottom, we've already got the x minus 3 and the x plus 2 taken care of. The only part that's missing is the x plus 4, which means that's what I'm going to multiply the numerator by, is the x plus 4. All right, so what do you get when you multiply 9 times the x plus 4? 9x plus 36. Okay, now let's start adding this together. X squared plus a 9x. Actually, we can't do that because that's an x, not an x squared, so we're going to have to leave that x squared. Let's see, there are no x's to add together, so we'll keep that 9x. And a negative 9 plus 36. What's a negative 9 plus 36? What is it? Plus what? 27. All over all that junk. X plus 2, x plus 4, and x minus 3. And that's the answer, right? Maybe. How do we know for sure? What do we got to do with the numerator? Factor it out. So can we factor x squared plus 9x plus 27? Are there factors of 27 that would add up to a 9? No. So yes, we are done. And that's our. I kind of warn you guys, that's a lot of work, especially finding that common denominator. That's the part that's going to get us. So we need to be real careful with that.